So thanks everyone for tuning in, and thanks to the Intersection Conference for organizing this. And yeah, like you said, my name is Szymon Kaliski, and I'm a designer and developer. And this talk is called On Rigor in Design and Research. So to give this talk a little bit of a context, I'd like to start to tell you by how I got here, because I don't think this is like the usual journey. So I studied computer science and interactive media roughly at the same time. And for me, this combination of these different viewpoints seemed super interesting. And at the time, I was mainly focused on making digital art, and I was playing a lot of music. So over time, while doing this, I realized that most of the music sounded like the software I was using. So I started exploring different ways of making my own tools to create the things I wanted to create. And I started working with something called MaxMSP, which is a visual programming language for musicians. And this allows you to build your own bespoke tools for making music. And this really got me hooked on this feedback loop of using the tools to be able to create what you want to create. So over time, I started using the same techniques for building visualizations for my music, and then exploring this whole art and science space with various interactive art pieces. So after college, I started freelancing in this creative coding space, and I was trying to work on art projects mostly. So some of them were or still are museum art pieces and art installations, as you can see on these videos here. And some of them were a bit more commercial, like this one, a huge data art piece that I helped create for Google I/O a couple of years back. So over time, I realized that the projects that I was most interested in, the ones that were pulling me the most, were ones concerned with data visualization, and I think in more general, how people work with and understand information. So while I was focusing on such projects over time, this made me gradually move on to working mostly with interfaces and data visualization projects. I like to call them information dance. I was trying to build basically the best interfaces and interactions for people working with big and complex data sets. So while doing that, I also got really interested in the medium itself, the medium of computation, and how programming and working with code could be different or hopefully better. So I worked on a lot of various research projects in the future of coding space. I was building things like NCLM, things like custom visual programming languages, interactive constraint solving systems, like various experiments around digital tools and interaction with information and code. So I kind of realized that there's been a common vector through all these projects that I've been working on, one that was combining computational design with rapid prototyping to solve these interface design challenges, basically, and especially in the space of complex digital tools. So to be able to focus on these problems and also to be able to create better solutions for them by incorporating more brainpower, I started a studio called Flow Control. We are a beauty research and development studio, and I just realized yesterday that we turned 5, which is kind of exciting and strange to say out loud. So in this talk, basically, I'm going to try to share with you the approach that we've been developing for working with these open-ended design challenges, like how we approach this kind of work. So before I get to the point, I wanted to start by saying, like, this talk tries to describe what seems to work well for us when dealing with these open-ended problems. And I like to put this asterisk that I'm not an expert in research or design. I have 0 academic research history. I don't aim to revolutionize anything like any science design processes or anything like that. Again, this is a process that seems to work for us, and I'd like to share with you how we go around that. So to circle back to the title of the talk, On Rigor in Design and Research. The title was actually inspired by a super short story from Borges, On Rigor in Science. And it's a story about this imaginary empire where cartographers wanted such an exact map of the kingdom that in order to achieve that, they've built another one of a scale 1:1 just right next over. So this is a quite interesting thought experiment, and it brings us to this famous quote from Alfred Korzybski. A map is not the territory it represents, but if correct, it has similar structure to the territory, which accounts for its usefulness. Or in other words, all models are wrong, but some are useful. So basically, if we think about a space of possible solutions, how we can explore this space without developing every possible end result. And I think this map territory relation problem is quite useful model for thinking about these open-ended search spaces. If you don't want to create all the possible solutions, as in building this map of one-to-one to the territory, how can you uncover enough of that map for it to be useful? And I think there's also another dimension to trying to solve this process of designing. This is a quote from a terrific paper from Antti Matuszczak and Michael Nielsen. What design processes could you take from Roman numerals to Hindu-Arabic numerals? It's another thought experiment. If you imagine yourself in times before Hindu-Arabic numerals existed, can you devise a design process to get to them? And I don't think our current methods of design are enough for this. And again, I don't postulate I have this solved in any way, but it's an interesting thing to keep in the back of our heads. And Brett Victor has a quote on the same topic. Back in the days of Roman numerals, basic multiplication was considered this incredibly technical concept that only official mathematicians could handle. Once the Arabic numerals came around, you could actually do arithmetic on paper, and we found out that 7-year-olds can understand multiplication. So it's not that the multiplication itself was difficult, it was just that the representation of numbers, that the interface was wrong. And I'd let you absorb it for a second. So, like I said, I'm not trying to turn this talk in this big hand-wavy open question one, but I think the last sentence especially is a very important thing to keep in mind for us as designers. There's this interesting point of how much of an impact an interface to something has, especially if we're trying to build things that should empower people, enable them to do more. So circling back to actually how we're trying to solve it, if we start with the map, I think that the old civilization game could be a quite nice metaphor here. It's a game where we're trying to build the biggest possible empire you can with the least amount of steps. So if you imagine the map is the solution space, so all the possible things we could do in a given problem. I think what happens most often in the waterfall model is that in the first iteration stage, we basically choose direction at random. Well, not exactly at random, like some azimuth is chosen. It's part on intuition, part on past experiences, and then we just go towards it. And as you can see, you can end up in a desert and not find anything interesting moving towards that thing. And there's also, it's hard to backtrack at that point if we spend so much time going in that direction. The agile methods, I think, are trying to be a little bit better by, instead of moving in the single direction, they try to make bigger and bigger circles in each sprint or iteration. And this has a chance of stumbling upon something really interesting, but again, uses a lot of moves to get to there. And remember, we're trying to optimize for taking as little of these steps as possible. And I think in both, again, there's a bit of sunk cost fallacy. If you already went so far, it's hard for us to backtrack and choose something else. And as you can see, even agile methods could lead to basically stomping on the desert. So what can we do about this? Dan Norman of the famous design of everyday things was already mentioned on this conference a couple of times, proposes a way of working where these multiple directions are explored at the same time. One promising direction towards the development of radical innovation is to modify the human-centered design process to require simultaneous development of multiple ideas and prototypes. By forcing the design team to simultaneously diverge into multiple directions, this enhances the chance of having some of these attempts start off in different design space, one that might possibly allow for a successful product. For us, this has been really transforming in how we approach these problems, but we're trying to do it not by developing the solutions immediately, but more so by probing the map and trying to find different things that seem interesting. And only after we have this outline of different things we could do, we start actually moving. So we try to do that by building prototypes. And there's this important thing about them, that the quality of the prototype should reflect the fidelity of the idea. So if your intuition or your idea is painted with very broad strokes, you shouldn't spend a lot of time developing it. You should build just enough that gives you an answer to the question you're trying to ask. And these prototypes are made to ask questions, to be able to understand the space that you're moving around better, to be able to uncover different layers of this map without actually building the end product. So here's a demonstration to try to visualize how that could work. So the prototypes that we're building allow us to discover these different layers and outlines of the map. We uncover just enough to have a feel, where should we go? So we have to remember about the map territory relation problem here. We don't need these prototypes to be production ready. They just have to allow us to have a feel for the space and just put the questions about it. And once we know which directions are interesting and where is the best possible outcome, or the one that we could see, we can move towards there fairly efficiently. So this is what a process like that might look like in reality. And I know this screen is kind of blurry, but that doesn't matter really that much. First of all, this is not a set of transitions through screens in an application. This is actually a map of the search space of different prototypes that we've built to try to understand what we're dealing with. So as you can see, we're trying to move in different directions all at the same time. And also some of them are dead ends, and that's okay, that's normal. And that's why we call them prototypes, because we can backtrack easily and choose different directions if something doesn't work out. So the good thing is some of them are not dead ends. And then we can hit a point where we know what to build towards. So basically, once we go to this process, we have a better feel of the solution space. We have this blurry outline of the map, and we know which directions are interesting to explore. So to give all of this hand-wavy explanation a little bit more of context, I want to take you through two projects from our recent history that took this sort of approach for solving problems. So first one is the work we did for European Space Agency in collaboration with a company called Recoded. So the question was, again, very open-ended, because that's what I'm trying to talk about. The question was how to lay out things in the ground control screens, while allowing these layouts to be created both in a visual, user-friendly way, and also have the same ideas drive the code and the components that we use to build those screens. As in, if you're an engineer, you want to be able to create that from code. So this is what a ground control system, a ground control room looks like. And you can notice a couple of things. I think the most important one is that most of the screens are not really interactive. And there's no keyboard and mouse connected to them. No one is clicking around them. They are just, quote unquote, for reading information and understanding what's going on in the system. So we wanted to optimize for this and basically create such a constraint that building things that don't make sense in that situation would be impossible. As in, scrolling and overflow shouldn't be allowed if there's a system you want to interact with. So we started by exploring a couple of ideas around how to divide space on the allowed some constraint size screen and do it in a way where the widget you can place on that space takes as much as possible. And we're exploring these different ideas by actually building quick prototypes around them. So each one of these 4 experiments was an actual URL that you could visit in your browser and play with it. So we wanted to get a feel for how it feels to use something that is almost there, like almost implemented. You can notice that basically all of them are just colorful rectangles on a screen, and that's by design, because again, we didn't want to focus on a design system, on proper use of fonts, of colors, while we were still unsure what the actual layouting thing is. So these first iterations were built only to understand the constraints of the solution space and how we can interact with them. Interesting thing is that the one we built first, the one on the left, was something that my intuition was telling me would be the best, But it turns out when you actually use it for some time, it's not as nice as the other ones we explored. So once we got that feeling and once we knew what felt right for this situation, we started to move towards more polished prototypes. So we were trying to focus more on like the first order and second order interactions, like how preference panes could work like in these situations, how resizing and keyboard navigation might work. Basically trying to build just enough of the different ideas to get a feel for how they would work if they were to create it properly in the final design system. And again, at this stage, we started slowly moving towards the design system that the European Space Agency has by introducing some of the colors and some of the fonts, but only just enough to have a feel that this could work, but not focusing on these final graphic design solutions. So this is how the final implementation looks like. And we went through a couple of more additional iterations. Turns out we needed tabs for different widgets. So you still want to be able to open something, but have it invisible. But this is something that came out later after we had settled on the actual layouting system that we worked with. And again, the important part here I'm trying to say is that these early prototypes allowed us to quickly get a feel for the interactions needed for such a bespoke layouting system. And then the graphic design mostly followed these constraints. So it wasn't like we first designed something in Figma and then we built it. It was more that the graphic design followed the constraints that we uncovered in the initial stages. And this brings me to the second example I want to share with you. This is the work we did with a startup called Molecule One, which is placed at the intersection of machine learning and molecular retrosynthesis. So a couple of big words. Let me explain what's going on. So the way the molecular retrosynthesis works is basically you design a target molecule. For example, if you're a chemist designing a new drug, you just draw out this target that you can see on the left side of the screen. And then Molecule One takes over and with machine learning designs a synthesis path to get to that solution. So basically which different molecules you want to get into a reaction and which reactions happen in which order to get to this final solution. But what actually happens is there's no single best solution. There's a lot of these synthesis plans that could get you to the same final solution. And if you imagine an interaction where you start with this and then you can see another one and another one and another one, each of them slightly different, but each of them leading to this final solution, it's not a usable interface really. And if there's more than a couple of these trees, and in reality there are, it's just impossible to use in that sense to be able to compare what I want to do as a chemist, like which one of them feels the best for the constraints I have. So we started working again by building prototypes. And this time we started by actually taking a step back and trying to explore what is in the data set. So we got a data set describing all possible synthesis trees for a given one final target from Molecule One. And then we created this bespoke visualization where we could see all of them at once. And we could play with it. We could scroll around, we could zoom in and out and explore basically what is in there. And this tree is actually pretty small, that the real one is much bigger, but that was just enough to like get the feel of what's going on. And there's two important things that we learned. One of them is that there's this clustering thing happening. So if you notice around some of these molecules, there's a bunch of situations where there's a couple of reactions and a couple more molecules. So basically most of the different trees share a chunk of that path, and then different subpaths differ. And two, some of the molecules appear in random various places of the tree. So the same substrate can be used in different reactions. So knowing that, we started exploring a ton of different ideas and again, quick prototypes to what we could do with these thousands of possible synthesis plans in the situation. And at some point, we proposed a couple of interactions where a chemist would start not by seeing the whole tree, but by iteratively building it from the solution. So by exploring and clicking and building it out. From various reasons, this wasn't really aligned with what Molecule One wanted to do, but it gave us this new starting point for exploring another interaction IDC which starting materials are used to build out this final molecule. And for this, again, we've built a bespoke tool working on the actual data set, because this is not something you can gain knowledge about by just graphic design. You need to have a feel for the space and know what's in there. So by building this tool and just drawing all of the starting materials for the different synthesis plants for that target molecule and showing them on the screen, and this is just 3 of them of possible thousands, you can already notice something important happening in here. The 3 of them in this part of the screen, the 3 of them are basically the same, only the last one changes. And it turns out that there's an actual chemical reason why that happens. And this is something we learned from molecule 1. It's basically how the target molecule is cut into different pieces can dictate this situation. So it made us think about this way of making this set browsable, wherein you start by a broad overview and then drill into different solutions. So this is a proposed final prototype. The column on the left visualizes different cuts on the final molecule, on the target that you want to get into. Here they are visualized by color, but in reality, it could be a line or anything else. That doesn't really matter. The next step, when you choose which set of cuts seems interesting, you get to a list of starting materials that can get you to there. And then by selecting a set of starting materials, you can finally see a different synthesis trees that use the starting materials through different reactions to get a target. So basically turn the situation around. I'm not trying to talk here about a lot about the actual solution that we've made, but more so about the process. So by the way of working with the actual data set and exploring what is in there, we were able to uncover a couple of things that we wouldn't think about if we were only using our graphic design parts of Brain. Basically, again, there's no even graphic design happening at all, but basically the design solution followed the exploration that we've made through these bespoke tools and through these prototypes. So to recap of what I'm trying to say is, first, these different prototypes allow us to uncover different layers of the map so we can have a feel for the solution space before we actually start moving on the territory. We can use them to make much better design decisions over time when navigating this territory, so our solution space. And again, map is not the territory it represents, but has similar structure to the territory. As in, we have to remember that the prototypes we're building should be able to allow us to ask better questions and design better solutions. They are not a brick into a final product. They are just these points that we use to see a little bit more of the map. I think that most design practices seem to go somewhere without explicitly thinking about this map. And I think that trying to think about it deliberately and uncover these different layers and solutions before you actually build them is a worthwhile thing to do. At least it seems to work for us. And I think there's also an interesting secondary thing to this, which is that the process of designing can itself be deliberately designed, experimented upon and improved upon. And this is something we try to do in our practice as well, which is after every project or even during it, we try to take a step back every once in a while and figure out if the approach that we're taking, as in the meta way of working with these solutions, actually makes sense. And then we try to iterate over it through different client projects and different things we built over time to be able to figure out what is the best way of solving these things. So this is how much I have. Again, this talk was on Rigor in design and research. I'm Szymon Kaliski, design and developer at Flow Control. If for any reason this sounds like an interesting project to work on, let me know. We're always looking for collaborators. And if you have an unusual problem like that, also let me know. Maybe I'll be able to help. Thank you all for listening. I'm open to questions, and also thanks to our sponsors.